The formation of our solar system. Long before there was a sun with planets in our solar system, there was a planetary nebula hanging around. It contained all the ingredients needed to create the sun and planets. It even contained the ingredients to make you and everything you see around you in everyday life. A nebula is a cloud-like structure in space made of gases and dust. The main gases in a nebula are usually hydrogen and helium. There is enough outward force called pressure to balance the inward force of gravity, which keeps the nebula in a happy, cloud-like shape in space. However, if the balance between pressure and gravity is disturbed, the cloud can flatten like a pancake and start the formation of a star. This is exactly what happened when our sun began to form. The nebula that formed our solar system is called the solar nebula. It was disturbed in some way that caused the cloud to flatten out. Scientists aren't exactly sure what happened because this occurred 4.6 billion years ago, long before human life appeared on the Earth. They do have a couple of ideas, one of which is that there was a star nearby in space that exploded called a supernova. The shock waves from this explosion caused the gravity of the cloud to be stronger than the pressure pushing out. This would have been enough to flatten out the nebula and cause it to begin to rotate like spinning pizza dough. Once the nebula flattened out and began to spin, material started to gather at the center of the flat disk shape. Once enough material gathered at the center, it started to heat up and glow. This would have been the very beginning of our sun, a star that scientists call a protostar. Eventually, this baby star heated up enough that it began a process called nuclear fusion, where hydrogen atoms are crashed together to make helium. This produces a huge amount of energy, and finally, a star is born. Nuclear fusion happens at the center or core of a star and radiates heat outward into space. At the same time the sun was forming, all the extra material flying around in space began to clump together in small, planet-like objects called planetesimals. Planetesimals bumped and crashed into each other and continued to build upon each other to make larger objects that eventually became the planets we know today. Those planets have differences depending on where in the solar system they formed. The inner planets, Mercury, Venus, Earth, and Mars, are all small, dense, and rocky, while the outer planets, Jupiter, Saturn, Uranus, and Neptune, are all very large, made mostly of gases and less dense than the inner planets. Scientists believe the reason for this is because it was too hot near the sun for the lighter gases to accumulate there. So those materials moved away from the hot center of the solar system. That meant that the inner planets kept all the heavy, solid materials like iron and nickel, while the outer planets were able to collect light gases like hydrogen and helium. Even though we weren't around to see the solar system form 4.6 billion years ago, scientists have been able to study objects like meteorites on Earth and in the solar system to gain clues as to how this process most likely happened. They are interested in finding out exactly how this might have led to life here on Earth and possibly in other places in our solar system and even in the universe.